Bismillahirrahmanirrahim. Assalamu alaikum class. Now we are going to have lecture 6. Course is statistical inference first, and before the mid exam this will be the last lecture. Topic is that we are going through with the point estimation and their properties. We have seen that unbiasedness, consistency, sufficiency, and efficiency and completeness are the major and main properties of a good estimator. But today we also see the least square and general linear model, their classical assumptions and the violation of classical assumptions, and also the least square under normality. We will revise the point estimation properties, and then we will see these topics also. Point estimation, as we know, are the functions that are used to find an approximate value of a population parameter. That parameter is unknown due to the population is not well defined, or sometimes population characteristics are unknown. That's why we try to find out with the help of samples the proper parameters which will represent the population. And these parameters that must be considered as a good parameters, or that have the good parameters that having the properties of a point estimators, unbiasedness, consistency, sufficiency, and efficiency. Let's see with this diagram that we have the mean is the central value. Then we say that our distribution follows the normality. And if the point estimator or mean has the minimum value maybe on the negative side, then we say that our distribution is negatively skewed, or in other case when our distribution is on the right side, is known as the positively skewed distribution. So sample used as a point estimator for the population has shown with the help of this diagram. Properties of point estimators are that it should be biased. Bias means that our estimates should be equal to the population parameter. There is no difference between the actual value and the estimated value, and if there difference exists, then it is known as the bias of the point estimator. We try to reduce it by increasing the sample size, or we find out its order of the biasness, that is known as the asymptotically biased estimators. Then other property of the point estimator is the consistency. Consistency means the estimators that have the minimum variances are known as the consistent estimators. This is in case of when we have more than 2 samples. So in case we see and select the sample that have the minimum variance, and it follows the sampling distribution. Then most efficient and unbiased estimator concept is there. The estimators are most efficient point estimator that have the smallest variances, and the efficient estimators, unbiased efficient estimator are those which are unbiased and also have the minimum variances. So it means that in a normal distribution, if the mean is considered more efficient than the median, but then the median have the same distribution, symmetrical distribution as compared to the mean. Point estimation have other properties of sufficiency. That means the estimator are sufficient if they utilizes the maximum information present of the population. And we also, when we define an estimate, we also give its point estimate and also an interval estimate, and then its testing is compulsory as it is logically in the statistical inference. So when we define a point estimate, we define its interval estimate. So What is the interval estimate? Interval estimate means you give a range of values in which your estimate will lie. That range or that interval is called the interval estimate, and we mostly it is known as the confidence interval. Confidence interval about our estimate. So confidence interval is, if you have 95% confidence interval, then it means there is a 5% significance level of that estimate. So we test on the level of significance that our estimate will follow the population parameter or not. So for the estimation procedure, we must give a point estimate and its interval estimate, and then we test our estimate for the possible rejection that we have, that null hypothesis. So common methods of finding the point estimates are that the process of point estimation involves utilizing the value of a statistic that is obtained from sample data to get the best estimate of the corresponding unknown parameter of the population. Several methods can be used to calculate the point estimator, and each method comes with different properties. These methods we will see and we will go through after the midterm exam. And these methods are, first method is method of movements. The method of movements of estimating parameters was introduced by a Russian, Shibashev. It starts by taking known facts about a population and then applying the facts to a sample of the population. The first step is to derive equations that relate the population movements to the unknown parameters. And the next step is to draw a sample of the population to be used to estimate the population movements. The equations derived in step 1 are then solved using the sample mean of the population movements. This procedure produces the best estimates of the unknown population parameters. There is also a method of maximum likelihood estimators, which we have little bit touched in when we are using the consistent estimators property. Maximum likelihood estimator method of point estimator attempts to find the unknown parameter that maximizes the likelihood function. It takes a known model and uses the value to compare data sets and find the most suitable match of the data. Then we have to find out the procedure that if we want to determine and to make a good estimator, there are two key features. First is the center of sampling distribution of the estimate is the same as that of the population. And second is the estimate has the smallest standard error when compared to the estimators. The example is given so that make the concept more clear. In the sampling and estimator, if we want to compare, and a probability density function is our example, then probability density function of X is in the first diagram you can see, and in the second probability density function of X bar is given to you. We will next demonstrate the variance of the distribution of X bar is smaller than that of X as depicted in the diagram. So variance of X bar is sigma square X bar, and it is that we find out variance of the samples X1 up to Xn divided by the N, and variance is we apply the variance. So 1 over n is the constant of variance, that is that becomes 1 over n square, and we apply the variance on all the variables. That gives us the variance of x1, gives us the sigma square of x and sigma square of xn up to so on, and the sigmas are all can be identical. So sigma square x up to sigma square xn, and then we have the n sigma square x. So n is cancelled with n square, and we are left with the sigma square x over n. So population variance is divided by n is equal to the sample variance. Unbiased and efficiency, if we want to see of the mean, sample mean, that can be seen with this formula that expected of x bar is equal to mu of x bar, and it is explained into the equations. Generalized estimators, we have lambda 1 x1 plus lambda 2 x2, and if we apply estimation on it, we can get that mu is equal to mu x, and if we put lambda 1 plus lambda 2 is equal to 1. So the unbiased and efficiency diagram is over here, the estimator B and estimator A. So estimator B has a larger variance as compared to estimator A. So estimator A is the more efficient and unbiased estimator. Unbiased and efficiency can be seen with the help of the formula that if we apply variances on lambda 1 x1 plus lambda 2 x2, then variance are multiplied with both, and there is a constant, there is a covariance of the product, and that value is equal to lambda 1 square sigma 1 square and lambda 2 square sigma 2 square. And if we take lambda 1 square plus lambda 2 square common, then we get sigma square x. So this can be, we add, if we put lambda 1 plus lambda 2 is equal to 1. So we have the, this equation is in the shape of 1 minus lambda 1 whole square plus lambda 1 square into sigma square x. And by taking their square, we can get this value. So the derivative of sigma square z by d, lambda 1 is equal to 0. So 4 lambda 1 minus 2 is equal to 0, and lambda 1 is equal to lambda 2 is equal to 0.5. So conflicts between unbiasedness and minimum variance is that the estimator A and estimator B, if we suppose two estimators that have alternative estimators of a population characteristic theta, one unbiased, the other biased, but with the smaller variances, how do you choose between them? So answer is we will choose the function which have the mean scale, minimum mean scale error. So similarly, these are equations are we have already proved and explained in the class. This is just for the revision and make it clear to you to the next topic. So in case of the estimator shown, estimator B is probably a little better than estimator A according to the mean scale criterion. Then there is an example of an observation that usually estimators of the variance is the sum of the square deviation around the sample mean divided by n minus 1. Typically, we have the standard deviation sum of x minus x bar square over n minus 1. Then also the variance formula and the estimator and the covariance and the estimator are given to you in this slide. Rho estimator is also given to you, and its formula relating to the consistency and unbiasedness. So probability limits and consistency, if we see, if n is equal to 1, the sample consists of a single observation, x bar is the same as x and its standard deviation is 50. So students, asymptotic properties of the estimators are, and this diagram shows it very well. We will see that how the shape of the distribution changes as the sample size is increased. So these are the different shapes. As the sample size is increased, the distribution shape is changing. So these are the examples. And then the consistency idea is there. An estimator of the population characteristics is said to be consistent if it satisfies two conditions. One is that it poses a probability limit, and so its distribution collapses to a skip as the sample size becomes large, and the skip is located at the true value of the population characteristics, which is shown by this diagram. So consistency, why we are interested in consistency when in practice we have finite samples? The answer is as a first approximation. The answer is that if we can show that an estimator is consistent, then we may be optimistic, but about its finite sample properties. Whereas in the estimator is inconsistent, we know that for finite samples, it will definitely be biased. So there are reasons for being cautious about preferring consistent estimators, and which are firstly that consistent estimator may be biased for finite samples, and secondly we are usually also interested in variances. Now this was all about the point estimation and its properties, and we have gone through very in detail in our previous 5 lectures, and it was the only revision. We will also have a little bit revision in the our physical class on the 21st November. Now our new topic is relating to the ordinary least square, and its procedure, its classical examples, and which are already very well known to the students of statistics, that the OLS is the best procedure for estimating a linear regression model only under certain assumptions. The word classical refers to its assumptions that are required to hold. So assumptions of the classical linear regression model are the regression model is linear, correctly specified, and has an additive error term. Second is the error term has a zero population mean. Third, and explanatory variables are uncorrelated with the error term. Fourth, observations of the error terms are uncorrelated with each other. So it means no serial correlation. The error terms has a constant variance. No explanatory variable is perfect linear function of any other explanatory variables. It means no perfect multicollinearity. The error term is normally distributed, not required. Essentially, the rest of the course details with what happens when one or more of these assumptions do not hold and what we can do to remedy the situation. So students, if these ordinary least square is relating to the topic of the regression. So if we see the little bit in summary, in briefly about the regression. So multiple regression is used to determine the effect of the number of independent variables on a single dependent variable. The different variables are combined in a linear way, and each has its own regression coefficient. The regression coefficient beta parameters reflect the independent contribution of each independent variable x to the variable of the dependent variable. That is the amount of variance in y that is accounted for by each x variable after all the other x variables have been accounted for. So a matrix formulation is of this type, where we have y as the dependent variable and x as the independent variables, and then its different forms are there. General linear model is that this is simply an extension of multiple regression, or alternatively multiple regression is just a simple form of the general linear model. So if we say something about multiple regression only looks at one independent variable y, whereas generalized linear model allows you to analyze several independent y variables in a linear combination. Multiple linear regression is a generalized linear model with only one variable, and we also use its ANOVA, t-test, f-test, and are also forms of generalized linear model. Then the parameters associated to the generalized linear models, we try to estimate them. And in linear regression, the parameter beta is estimated so that the best prediction of y can be obtained. So this is all about the lecture number 6 relating to the topic of point estimation and its properties, unbiasedness, consistency, efficiency, sufficiency, and completeness. And little bit we have touched the least square or the generalized linear model and its classical properties, and the violation of the properties are also already given to you as an assignment, first assignment in the class. So students, I'm sure when you will go through this video, the lecture in the class will be more easy and simple for you until the class we will conduct on 21st. Allah Hafiz, take care. God bless us all. Thank you.